Good morning, children. Today we are here to discuss Unit 6 Structure of Atom of 10th class. Within this topic, now we are discussing quantum numbers. Within that, we have completed two quantum numbers. What is meant by quantum number? We have studied principal quantum number as well as azimuthal quantum number. Also, we have completed. Principal quantum number was discovered by whom? There, Niels Bohr, whose value is what? N has taken their small n. Positive integers 1, 2, 3, 4, so on. Azimuthal quantum number is nothing but what discovered by Sommerfeld. It depends upon principal quantum number and one less than the top principal quantum number, whereas principal quantum number gives about size as well as energy. Azimuthal quantum number gives about shape of the orbital. Now coming to our magnetic quantum number. This magnetic quantum number was discovered by whom? There, Landy. He discovered and he designated with M at subscript by keeping small n. Means it depends upon azimuthal quantum number. Magnetic quantum number, M indicates magnetic quantum number depending upon azimuthal quantum number. What does this magnetic quantum number gives information? It gives information about total number of orbitals in subshell. In subshell, how many number of orbitals are existing? How many number of orbitals existing? And orientation of those orbitals. Orientation of those orbitals, it gives information. Next one is nothing but what it also gives. It yields projection of angular momentum of an electron. How this particular orbital is orienting around its own axis, along given axis. What will be the axis there? X-axis, Y-axis, Z-axis, three-dimensional axis will be there. On that three-dimensional axis, angular momentum, the momentum of orbitals. Suborbitals, which are orbitals means what? Consisting of subshells. Suborbitals, how they are orienting that particular concept on given angular momentum of corresponding orbital along that particular axis. Along that particular axis, how it takes place, we are going to study about that particular point within magnetic quantum number. This magnetic quantum number depends upon azimuthal quantum number, that is L represent azimuthal quantum number, and indirectly as it is depending upon L azimuthal quantum number, this azimuthal quantum number depend upon what? Principal quantum number. Therefore, this ML means what? Magnetic quantum number indirectly depend upon principal quantum number. It depends upon what kind? Principal quantum number, that is the value. For a given value of L, the range will be existing in between minus L to the top plus L, it will be existing. For example, as I said, it is indirectly depend upon N, directly depend upon what? L. If I am taking N is equal to 4, means what? N is equal to 1 is K shell, N is equal to 2 is L shell, N is equal to 3 is M shell, N is equal to 4 means what? Here it is N shell means what? L will be having how many values? 3 values. If N is equal to 4, L is equal to 0, 1, 2, 3, it will be existing. 3 it is having there itself. Within this particular 3, how many possibles will be existing? Minus 3 to plus 3 it will be existing. That is minus 3, minus 2, minus 1, 0, 1, 2, 3, so on. 1, 2, 3, 4, 5, 6, 7. 7 values. 7 different orientations it can be taken place as magnetic quantum number. Means what? It represents one orbital. What is that orbital here? F orbital it represents, which will be having 7 subshells. 7 subshells will be existing. Those F orbital, it will be orienting in 7 different directions. 7 different directions it can be taken place. The angular momentum of each orbit can be taken place in how many ways? 7 different ways they can be taken place. That is the thing we can understand there itself. Next point is what? Total number of orbitals given in subshells is a function of value L. It is mainly depending upon the function value of what? L by given formula called as 2L plus 1. 2L plus 1. For example, I have taken L azimuthal quantum number. Given formula is what? 2L plus 1 I have taken there. Possible values of ML means what? Orientations. How many orientations does an orbital can exist? Coming to first of all, L is equal to 0 if I have taken 2 into 0 is 0 plus 1, that is equal to 1. It is having only possible orientation of one orientation can be get existing. Here that one orientation of orbital will be which orbital? L is equal to 0 means which orbital? S orbital. N is equal to 1 means what is orbital? P orbital. N is equal to 2 means what? D orbital. L is equal to 3 means what? F orbital. So that would have been shape of the orbital and energy existing S orbital. It is having one orientation of S orbital. It can orient around its own axis in all three different within 3-dimensional figure there. Second one is what? If I am taking L is equal to 1, it belongs to which orbital? P orbital. 2 into 1 plus 1, 2 1s are 2, 2 plus 1 is 3. Total how many possibilities will be there orientations? 3 possibilities will be there. Therefore, P orbital will be divided into 3 subblocks, that is Px, one is Px, other one is Py, other one is Pz. Px orbital is existing its own orientation, x-axis, y-axis, z-axis. Px is having its own orientation, angular momentum along that particular axis, corresponding axis it is taking place. This is one orientation. And Py orbital is orienting here. This is what? Second orientation. And if you go for third one, this is third orientation on Pz orbital. Therefore, Px orbital orienting its own on a long x-axis. Py orbital orient on what? Angular momentum of the orbital will be taking place along y-axis. Pz will be orienting on what? Pz orbital along its axis it will be taking place. If I am taking L is equal to 2, d orbital it is 2 into 2 is what? 4, 4 plus 1 is what? 5. Therefore, D block will be having 5 subshells. How many subshells here? 5 subshells will be there. 1, 2, 3, 1, 2, 3, 4 and 5 subshells. First subshell will be having dxy, dyz, dzx, dx square minus y square, dz square. These many orbitals, 1, 2, 3, 4, 5 suborbitals will be existing. First suborbital is what? dy, dxy. This xy orbital double dumbbell shape. It is what? It is spherical in shape. It is in what shape? Dumbbell shape. Here it is in what shape? Double dumbbell shape. Therefore, 2 dumbbells are existing there. Within xy plane, these orbitals, if they won't exist on axis, in between that axis they will be existing. In this way, xy plane it will be existing. YZ plane, one orientation will be taken place. Angular momentum of along xy plane will be taken place. Along YZ plane, angular momentum corresponding to that particular axis, they will be orientating. And ZX plane they will be orientating, as well as X plane as well as Y. On X axis as well as Y axis they are oriented. On Z axis they will orient. How many orientations are there? 1, 2, 3, 4, 5 orientations are taking place. Therefore, that magnetic quantum number gives about what? Number of subshells existing simultaneously, orientation of orbital. that each orbital will have one subshell. For example, S orbital is having one subshell, P orbital 3 subshells, D orbital 5 subshells, F orbital 7 subshells. For each subshell will accommodate how many electrons? 2 electrons they can be accommodated. 1 electron will be in upward arrow, other electron will be downward arrow. Therefore, S orbital consisting of 2 electrons, P orbital consisting of 1, 2, 3, 4, 5, 6 orbitals, 6 electrons. D orbital is what? 2, 5 are 10. Each orbital will be having 2 electrons. 2 into 1 is 2 into 2 if I am doing it up. 1 2s are 2. 2, 2 3s are 6, into 2 if I am doing 2 5s are 10, D orbital will be having 10. If I go for F orbital, how many are there? 1, 2, 3, 4, 5, 6, 7. If I am considering this is an F orbital block. 1, 2, 3, 4, 5, 6, 7. Now what happened? Each orbital consisting of how many electrons? 2 electrons. Therefore, 2 into 7 will be given as how many electrons there? 14 electrons can be accommodated. Whereas P orbital is splitting up into Px, Py, Pz. D orbital is splitting up into dxy, dzx, dyx, dzx, dx square, y square, dz square. So these orbitals are called as degenerated orbitals. What orbitals we can call it up here? P orbital, D orbital, F orbital are called as degenerated orbitals. Why they are called as degenerated orbital means what? Each subshell will have same amount of energy. Each subshell will have what energy? Same amount of energy will be existing in each subshell. So that what happens? Electron, it won't be get paired up, it will be going singularly. Singularly they will occupy in each block. Later on pairing will be taken place as it is degenerated orbital. Same amount of energy will be there. First electron occupied here, second electron here, third electron here. After completely off filled, then pairing will be get stopped for this particular degenerated orbitals. This is total concept about magnetic quantum number, which was discovered by Landy. Next topic is electron spin quantum number. This electron spin quantum number was discovered by Alan Blake as well as Lord Smith. Both have discovered this particular quantum number, which is represented as MS. S indicates spin quantum number. What does the spin quantum number gives information? It is an independent of 3 quantum number, that is what? Principal quantum number, azimuthal quantum number, magnetic quantum number. It is independent of these 3 quantum numbers. It gives information about in which direction electron is spinning, in which direction within an orbital, in which direction within an orbital, in which direction the electron is spinning can be get identified by this particular spin quantum number, which has values of possible values of plus of, other one is what? Minus of, we can give it up. Plus of as well as what? Minus of, we can give it up those values. Not only that one, it gives information about electron behavior of an electron. For example, if I take alkali metals as well as alkaline earth metals, within that alkali metals I have taken sodium vapor lamp. Sodium vapor lamp emits yellow color light. The yellow color light will be having, it emits the yellow color light, which will be existing of double slit in nature, which cannot be seen with our eye, but it can be get caught by high resolution of one device that is called as spectroscopy. By using that particular device, spectroscope concept, high resolution of spectroscope device, if you observe, double slitting of that particular color can be easily identified. This nature will be existing in these 2 elements, first A group element as well as second A group element. That particular concept can be, that information can be that is happening due to behavior of electrons. That such type of behavior can be easily identified by spin quantum number. What number? Spin quantum number. Now coming to what? Positive plus half as well as negative half I have given there. If I go for positive values of ms, what direction I have taken here? Positive direction means what? Upward direction I have taken. Upward spin and negative arrow will be existing in upward direction. If it is downward spin of electron is existing in both downward spin arrow, that is what downward arrow. Not only that one, it determines whether atom has ability to produce magnetic field or not. To produce magnetic field, whether there is an ability to produce magnetic field or not can also be determined by electron spin quantum number. I have taken two spins, one is clockwise spin, other one is anti-clockwise spin. If I am considering clockwise spin is upward spin, anti-clockwise is of downward spin, therefore in opposite direction vice versa they can be existing. If both are positive means what? Parallel upspin only existing, only upspin is existing, then what it is called as parallel spin. Both are downward spin means what? It is also called as what? Parallel spin, we can give it up. If one positive is there and one negative is there, it is called as opposite spin. It is called as what? Opposite spin. This is the total concept about spin quantum number. By this we have completed total quantum numbers, children. In first part we have completed 2. In this part we have completed 2. Thank you, children.